Now we will discuss about the constructional features. Okay, so some important points we will discuss. First is the stator. So the stator, it is going to be a stationary part, right? So first point here is it is a stationary part of the DC machine. So even in AC machine you are going to have a stator. And what about the material? It should be a material of high permeability, right? Because it has to complete the flux path, as it completes the flux path, right? So we have already seen, if this is the field poles, right, then the coils will be present like this. Now the stator is going to be this stationary part, and it is going to help complete the flux path. Okay, so this is going to be the flux path. If this is north and south pole, then this is how the flux path will be completed. Here also you are going to have a field coil. Next is the field poles, right? The field poles are a part of the stator, right? This is the field poles, and this entire thing is called as the stator, entire stationary part. So you can see that these poles, they have a large cross section area, right? So this is to ensure that the flux is distributed uniformly. So you can write, they have a large cross section towards the rotor side, right? Where is the rotor? The rotor is here, towards the rotor side, to ensure better flux distribution. Okay, and they are also going to be acting as a mechanical support to the field coils. And a few more terminologies that you should know here. So this is the entire pole, right? Now this part is called as the pole core, and this part is called as the pole shoe. Okay, and this front part what you have, that is facing the rotor, that is going to be called as the pole face. So you should be familiar with these terms. Next is the rotor, or it is also called as the armature. So this is the rotating part of the machine, right? And it will carry the coils. So it is slotted to accommodate the coils, and these coils, they are often called as armature windings, right? So we will discuss more about the windings later. Next is the commutator. So what does the commutator do? It will ensure that if it is a motor, then it will ensure unidirectional torque, and if it is a generator, then it will ensure that the power that you are getting is a unidirectional power, that is DC power. Now when we were discussing the basic construction, we discussed only one coil, okay, and each end is connected to one half ring, or what you call as split ring, right? In actuality there will be a number of coils that are present, right? So it is actually the commutator, it is going to be like this. Okay, so you can consider it like a cylinder on which there are multiple segments. Okay, so this is how, and each of the segment, they will be separated by an insulating material. Okay, so that point is important. Each of these are segments, and the coils are going to be connected like this. Okay, and each of these segments, they are insulated by some insulating material. So each commutator segment is separated by means of an insulating material. Okay. The next part is the brushes. So these brushes are responsible to convert into the unidirectional torque or unidirectional voltage, right? So they slide over these commutator segments, right? So they are basically collecting or delivering the current depending on whether it is a generator or a transformer. So you can write commutator segments or commutator slides on the brushes as the rotor rotates, and they collect or deliver current depending on whether it is generator or motor. Now the material that is used to make the brush is carbon, okay? So made of carbon or even graphite can be used, okay? And sometimes a mixture of carbon and graphite. Next, finally, the most complex part of the DC machine is the armature windings. So how the windings are placed, okay? So there are different ways in which the windings are placed, but the prominent ones are lap winding and wave winding. We will discuss only about these two. So before we discuss about these, we need to understand a few terms, few important terms. So the very first one is called as pole pitch. So what is this pole pitch? Now if you consider two poles, you can see that if you complete one entire rotation, that will be 360 degrees, right? Now what is the angular distance between adjacent poles? One is the north pole and other is the south pole here, and you have only two poles. What is the angular distance? They are placed at 180 degrees apart, right? So that is called as the pole pitch. Angular distance between two adjacent poles. Now when there are only two poles, it is pretty straightforward, but when you are having more than that, then we need to express pole pitch in terms of electrical as well as mechanical degrees. We need to know the difference. So for example, you take the 4-pole machine. So here the poles are going to be north, south, north and south. Okay, so understand that we are not talking about these two will not be north and south. Now these two will constitute one pole, and then these two will constitute one pole, these two will constitute one pole. Okay, so now what is the angular distance between two adjacent poles? From here to here, then there are 4 poles, right? So 360 by 4, it is going to be 90 degrees between each pole. But this is the mechanical degrees. If you consider in terms of electrical degrees, always the pole pitch is going to be 180 degrees between adjacent poles. So between this north and south, the pole pitch in electrical degrees is 180 degrees, whereas the pole pitch in mechanical degrees, it is going to be 360 degrees by the number of poles. So the pole pitch is 180 degrees in electrical degrees always, and 360 degrees by P in mechanical degrees, where P is number of poles. The next term is the coil span. So if you consider the coil, this is going to be in different slots and it is going to come back to the commutator segment. There is going to be a commutator segment here. So these will be attached to different commutator segments. Now as I have told before, these conductors, they will be placed in the slots of the rotor, right? So now let us say this rotor slot we take as number 1, okay, and there are in between there are a number of slots and so on. The final slot is, let us say, number 7. Okay, then what will be the coil span? It will be the slot difference between the two conductors of the same coil. So here it is 1 and 7, the coil span will be 6. Okay, so that is what is coil span. Next is full pitch winding. So this is nothing but if the coil span it is equal to the pole pitch, then it is called as a full pitch winding. Otherwise it will be called as a fractional pitch winding. So in full pitch winding, pole pitch will be equal to the coil span. Okay, otherwise it is called fractional pitch winding. Next, what is a coil? Coil side and a turn. So if you consider one coil like this, okay, so this is a coil of one turn and this one side is called as the coil side. Okay, so each of these sides they will be put in the armature slots. So this is one coil side. Similarly, this is also one coil side. So one coil is going to have two coil sides, but this is called as a coil of single turn. Okay, there might be coil of multiple turns, so which will be something like this, right? So here you can see this is two turns, coil of two turns. Now here there are this is one coil side, this is another coil side, this is one, this is another coil side. So you have four coil sides. Next is single layer and double layer windings. So here what is going to happen? If this is the slot, one single slot in the rotor, okay, and if a single conductor is going to be placed here, so this is the conductor that is placed here, this is called a single layer. But what is going to happen if you keep two conductors one over the other? This is called as double layer, okay, and this is also called as double layer. There is one coil here, another coil here, another coil here. This is also called as a double layer. Okay, so you can write it down. This is single layer and these both are double layer. Next, progressive and retrogressive winding. So what is the difference between these two? If you take the commutator segments like this, right? So here you have one commutator segment, this is another commutator segment, this is the insulator in between. Now what is happening in a progressive winding? In progressive winding, what happens is the coil, it will start on one commutator segment and then it will end on a commutator segment that is after that. Okay, whereas in a retrogressive winding, what is going to happen? These are two commutator segments. Now the first coil is going to start here and the end of this coil is going to go back, okay, to the previous commutator segment. This is called as the retrogressive winding. Next is front pitch and back pitch. So here once again we will consider the commutator segments. So this is one commutator segment and here you have another. Totally three commutator segments you have. Okay. So now let us say one conductor is starting like this and the other end is connected to the next commutator segment, progressive winding, right? Now this is again connected to another coil and this is connected to the next commutator segment. Okay, so now remember these are different, connected in different slots. All these coil sides, they are connected in different slots. Okay, now the distance in terms of rotor slots in between this and this, see both of them, they are connected to the same commutator segment, right? So what will be the distance in terms of rotor slots in between this and this? That is called as the front pitch. Okay, and what about the back pitch? The back pitch is the distance from this conductor to its own coil side. Okay, so YF is the front pitch and YB is the back pitch. Now we will discuss a bit about the lap and wave winding. Not go into too much detail, just a basic understanding. Now the machine poles, they are going to be like this, right? So if you're considering a 4-pole machine, if this is north, this will be south, this will be north again, and this will be south. So whenever you are showing the windings, you are going to represent these poles like this. This is the first pole, this is the second pole, third and fourth. Okay. So these are usually normally in the cylindrical manner, right? But just for the sake of representation of the windings, we take it in a 2-dimensional format. Okay. So if this is north, then this will be south pole, this will be north, and again this will be south pole. Next, the rotor slots, right? So how will be the rotor? This is going to be the rotor, and there are going to be slots in between, right? In each of the slots there are going to be conductors. Now let us say the number of conductors is Z. Okay, that means what will be the number of coils? Number of coils is going to be Z by 2, because in each coil there is going to be 2 conductors. And then number of poles, if you are taking as P, here P is equal to 4, but in general we will take it as P. Okay. Then the number of conductors that are under each of these poles, right? So if this is one pole, then under this how many conductors are present? So that is going to be the total number of conductors divided by the number of poles. Okay. So number of conductors per pole, this is going to be Z by P. Okay. So one, let us say this is one conductor, 2, 3 and so on till Z by P. Okay. And then next what we have the commutator segment. So this is also usually in a round shape, right? So this will be the commutator actually. There are going to be various segments, right? And each of these segments, they are separated by insulating materials. So that commutator, it is in a round shape, that also we are representing in a flat shape. Okay. So this is one commutator segment, this is the insulating material, and once again you have another segment and so on like that. Okay. Now if this first conductor, this is connected to this commutator segment, then the other side of this, let us say this is connected here. Okay. Now which commutator segment it will be connected to? The next commutator segment. Okay. So this is for the lap winding. Now what is this distance? This distance is the back pitch. Now after this coil ends here, another coil will start. Okay. And this coil, let us say it is like this. Then this distance is the front pitch, YF, right? And then once again this is going to go on like this. With the, if you know the back pitch, then again that much distance later you are going to have the second side of this coil. So this is how the lap winding is going to be. Now one important point regarding the lap winding. What is that? The number of parallel paths in lap winding is equal to the number of poles, that is P, and usually the number of parallel paths you represent with capital A. Okay, so don't confuse it with amperes. The lap winding, it is going to look something like this. Let us say this is the entire DC machine. Then there are going to be, let us say we are taking 4 number of poles. Okay, so here there are going to be 4 number of brushes. So this is brush 2, this is brush 3 and this is brush 3. Okay. Now what is going to happen? 2 of the brushes are going to have the same polarity, plus and plus, and other 2 brushes they are going to have negative polarity. Okay. So this is going to be one terminal, this is the positive terminal, and these 2 negative terminal, they are going to be, they are going to form one single terminal. Next is wave winding. Here how are the windings placed? Let us say this is the commutator and here you have the segments. Okay. Now the first coil, let us say this is starting like this. Okay. So this is the portion of the conductor where it is going through the slotted rotor. Okay. So it is going like this and the next part it is going to be like this. So you can see that this is called as the commutator pitch YC. YC is the commutator pitch. For a lap winding, what was the commutator pitch? It was simply 1 because the conductor ended at the adjacent commutator. Okay, if it is starting at one point, at the next commutator only it is ending. Okay, but that is not the case in a wave winding. Okay, so this is the commutator pitch. Then what about this distance? In between there are going to be a number of slots, right? So that distance is as it is the back pitch, YB. Okay, then where will the next conductor start? So this is going to be, if it is going to start like this, then the distance between this and this will be the front pitch. Okay, and once again it will go on continue like that.